In this video, we continue the pointer discussion. We'll talk about pointer arithmetic, pointer initialization, and finally pointer comparison. Pointer arithmetic, we can create a variable for an array. So numbers array equals, and then we set some values for the array. We create a pointer to an integer type, and we set its address to the numbers array, meaning hold the address where the array starts. And we can, well, first of all, we can count, right? Let's count the number pointer. So let's see what value. So if we are correct, if we are saying that when we do an assignment, number pointer equals numbers, that we hold the address where 3 is stored. Thus, then we should see 3 displayed. And we do say see 3 displayed. So now we can create a loop to iterate the array. However, we're not going to use array notation. We'll do that, and then we'll simply say, okay, point to the next address. It's important to understand that number plus plus is actually doing I times 4. Why 4? Because an int type is stored in 4 bytes of data. So let's see what happens. And we do get the array values. And that's good. Let's make sure that we completely understand and drill the point home that number pointer stores address. Give me the address that you store at the first pointer, and it has the value at that address, right? So let's make sure that we display it as a long and not in hex. And we start at address 52. Of course, a long, big number, we're not going to iterate the whole, say the whole number, but then it's 52. We increase by 4, 56. The next one starts at 60, 64, 68, and the values correspond to the array. We can also create the same loop however, now we are going to iterate in reverse, and we display the same output, and we just create an end line here. And let's run this. Well, instead of cutting it, I should copy it, right? Okay, so now let's go. And we iterate the array in ascending order, and then we iterate in descending order. And it's important to understand that number pointer stores address ending in 36, and that address has the value 3. And the same for the next value in the array. It's stored at address ending in 40, stores the value 8. So that should hopefully clear things up for students, right? So this array starts at address 36 and the last value stored in address starting at 52. Next topic I wanted to briefly discuss is pointer initialization. We already know that we can initialize pointers by pointing to the address of a variable. So we create a pointer here, and then we assign this value to the address of numbers. And we can also create an array and we can create a pointer to the array, and we can set its value to the first address of the array. We can also create a pointer and assign the value 0 to it, meaning don't point to anything. In operating systems, usually the address 0 is stored for the reserved for the operator, and it's read-only, so the pointer will not harm it. We can also say pointer, set it to the macro null, and in C++ 11 we can say null pointer. And one more thing, we can do this. Of course, I'll change the numbers. So we can say only this, sorry. So this is equivalent to this. So that's important to understand. The last topic I want to cover in this video is pointer comparison. We can compare pointers using all the relational operators. Just make sure that you understand and that you know what you are comparing. For example, if we have a number and we have a pointer that points to that number, we can say if the address number equals to number pointer, then number pointer holds the address where number is stored. And we run this code, and that's the case, right? So this value is an address, ampersand number, and if we say number pointer without dereferencing it, then we are referring to its address. Don't forget that we can get the value held at the address that number pointer holds, which is number, and that value is 10, so equals 10. Then we can say number pointers stores the address where number is stored and numbers value is 10. And we run the code and we get what we expect. The important thing to understand is, what am I comparing? You want to compare addresses? Use the address operator. You want to compare values? Dereference the pointer. So that is important to understand. And that's all I will say as far as pointers. Well, one more example. Let's create an array of numbers, and let's just create an array of 3. Of course, we have to tell that it's an array. So then we can say if numbers of 0 equals less than numbers of 1, this is true because numbers of 0 is stored at an address and numbers of 1 is stored at address of n plus 1. And we run it, and that's the case. It's important to understand that. Now we can also compare the values. If numbers of 0 less than, well, in this case we say greater than, right? Because 2 is greater than 1. And numbers of 1, then we say true because 2 is greater than 1. So here we compare the values stored at address n and address n plus 1, and over here we are comparing address n to address n plus 1, and we run it. Let me see, numbers of 0. What did I do here? Okay, what? Sometimes demos get to me. Well, it was displaying, and again I did it to myself by not using the inline operator. Okay, sorry for the confusion. So the important thing to understand when you are comparing is, am I comparing addresses or am I comparing values? And that concludes this video.